Hi everyone, it's Albert. Today let's solve another classic coding interview question, validate binary search tree. And before we start, don't forget to subscribe to my channel. I'll be constantly solving good and classic LeetCode questions with clear explanation, animation, and visualization. Now let's look at the question. In this question, we're given the root of a binary tree, and we have to determine if it is a valid binary search tree. And a valid binary search tree is defined as the following. The left subtree of a node contains only nodes with keys less than the node's key. And the right subtree of a node contains only nodes with keys greater than the node's key. And last but not least, both the left and right subtrees must also be a binary search tree. So for example 1, for this binary tree 213, it is a binary search tree. But for example 2, this binary tree, because this right node 4, it is less than the root node 5, so it is not a binary search tree. And this is a really good coding interview question because first, it requires you to be very familiar with the three requirements of binary search tree. And if you remember from last week's video, for linked list or tree type of questions, we can use either iteration or recursion approach to solve these kind of problems. For the recursion approach, the key is to write the correct base conditions. And for iteration approach, we will need a pre-node, a pre-pointer. And the solution code is actually exactly the same as the question 94 binary tree in order traversal. And why in order traversal? Because it is another very important property of binary search tree that the binary search tree in order traversal will become a sorted array. Now let's look at the code. Okay, and first, let's look at the recursion approach. And for recursion, we will define a separate DFS function, and it will take in 3 arguments: the node, the minimum, and the maximum value we have so far of the current node. And the base condition of the DFS function, if the root is null, then we will just return true. And based on the definition of a binary search tree, if the current node value is smaller or equal to the minimum value, or it is larger or equal to the maximum value, then it means that it will not be a binary search tree. So we will just return false. And then we will recurse into the left and right subtree. But for the left subtree, the maximum value will become the value of the current node. And for the right subtree, the minimum value will become the value of the current node. And here we'll use this tree as an example. And for this tree, the left side is a binary search tree, but the right side is not. And first, let's run recursion on the left side. So for each node, the DFS call will be looking like this. And at the leaf nodes, because of this base condition that empty node is also considered a valid binary search tree, so the leaf node 3 and 5, you will get return value of true of both of their empty left and right child. And next, let's check at node 3 and 5. At node 3, its current node value, it sits between the minimum and the maximum value. And for node 5, its value 5 is between 4 and 6. So they are both a valid binary search tree node. So they will also return true to the root. And at node 4, its value 4 is also between the minimum and the maximum value. So it will return true to the root. So we can see that the left subtree is a valid binary search tree. And next, let's look into the right subtree. And similarly, at the leaf node 2, you will get return value of true of its empty left and right child. But at node 2, you can see that its node value 2, it is less than its minimum value 7, which means that at node 2, it is not a valid binary search tree node. So it will return false to its parent. And because in the DFS function, we are returning the end result of the Boolean values of the left and right subtree, and since here at node 7, we got a false from the right subtree, so it will return false to the root. So at the root, node 6, even though the left subtree is a valid binary search tree, but the right subtree is not, and it violates the third requirements of the valid binary search tree. So this tree, it is not a valid binary search tree. And next, let's look into the iteration approach. And the code for iteration approach is exactly the same as performing the in-order traversal of binary tree. Besides that, we have a pre node here for checking the values of the previous node and the current node for the requirement of binary search tree. And as we mentioned, the in-order traversal of binary search tree should be a sorted array. So you can just picture this tree into an array, and you can immediately see that this is not a sorted array. So this could not be a binary search tree. And now let's see how iteration works in action. So for in-order traversal, we will traverse all the left nodes first. So we will put a node 6, 4, 3 into stack. And then at node 3, it is a leaf node, so we will start popping the nodes out. And here we will pop 3 out, so it will become the pre-node. And here we are at node 4. And because pre-node 3, its value is smaller than 4, so far it is still a valid binary search tree. And here we'll pop a 4 out, and because node 4, it has a right node 5, so the pre-node will become 4, and now we are at 5. And because 4 is smaller than 5, so it's still valid. And now we're at node 7, and the pre-node is 6, and 6 is smaller than 7, so still good. And then we'll pop 7 out. So node 7, it has a right node, so now we are at node 2, and the pre-node is 7. Okay, and here you can see that the pre-node 7, it is larger than the current node 2, which means that it hits this condition, and the array is not sorted anymore. So at this point, we see that this is not a valid binary search tree, so we will just return false. And this will conclude the algorithm. Finally, let's review. So again, for linked list or tree type of question, you can usually use iteration and recursion approach to solve this kind of questions. And for the recursion approach, the key is to write the base condition correct. And for the iteration approach, it is important to have the pre-node defined. And the solution is basically the same as the question 94 binary tree in order traversal. So make sure to check out and solve this question as well. And the key property of binary search tree that we use in the iteration approach is the in-order traversal of BST is a sorted array. And I would say that for questions related to binary search tree, 80% of the time you will have to use this property. And the time complexity of both approach are linear, big O of n. And the space complexity, big O of n. And that will be all for today. Thanks for watching. If you like this video, please give it a like and subscribe to my channel, and I will see you in the next one.